Hi, and welcome to another exciting edition of Game Shader Programming. My name is Nate Nessler, and this is for Hyperactive Studios. Okay, so now we're going to look at depth shaders. I was going to jump right into screen space ambient occlusion, not global illumination. Although I did look into that too, but I think I might have found a way for doing that one. However, I need to go over some more of the basic stuff before we go jumping right in there. And so yeah, it would be an issue if I did that. So what you want to do is go here and create a new effect shader, and you want to hit up your pass-through shader, wherever it is. Yeah, that's the pass-through shader. So you're going to copy and paste your stuff from the pass-through shader into here, and just call it depth here. So go to like create, effect, let it pop up, choose a CGFX, click in here for the next, select the empty, and then name it like depth or depth shader or depth whatever. I don't care, whatever you want to call it, something like that. And then you're going to paste in your code from your pass-through in here. Go ahead and change this to depth right here for this part, and change your date. All this stuff is the same up here. We did get rid of the other parts of the world transform matrices, like inverse and view, inverse, and all that stuff. So we toasted those, got rid of them. And now here underneath the artist controls, we have something different here, something new. Sorry, let me go back to my depth here for the controls. And this is optimized for teapot. So this gets into the depth pass, or shall we say the depth buffer type stuff. And this is how we can figure out, based on image values, of how far back something is in the scene for doing the shading on it. And this is pretty cool, really. And we've made this materialize basically in the actual screen here, so that way you can see the effect of it. Right now this is optimized for the teapot, not the plane so much in the background here. Matter of fact, thinking about it, let me scale in the plane some. And so you can see it just falls off fairly quickly, I have to say. And that's done for the teapot purposes, because you don't have that much gradation here between this point and this point here. It's a very short distance, so they've been keyed in pretty close together. I mean, you're only talking a difference of like 2 units here for the entire distance of this near and far here. So it's tuned in pretty tight, and that's why you're getting such a sharp transition from white to black here. That's because they have very little distance to do this over. We also have a gamma roll-off, or just basically the gamma, which controls how bright this shader gets, as you can see there. If you want more of a fall off, just simply bring down your gamma. And it goes down to too small, really. So it depends on just how much of a variation you want. Here we are back at 1.0 again. And then you can set your near and far distance. These aren't slider based here. You can actually just hand enter the values, although they could be made sliders. Near and far color. The nearest color is going to be white, and the far color is going to be black. This actually works out quite good. And the reason why is because a lot of times you're going to store your depth into the alpha channel, so it would just be a black and white grayscale value. And you don't need RGB for this. So FYI, that will work for us. Okay, so we need to create these here so we can see our depth occur on screen. So for the first annotation here, we're going to do a float 4 here, near color, open less than sign, string UI equals near color, close quotes, semicolon, string UI widget equals, in quotes, color, close quotes, semicolon, open greater than sign equals curly brace here, 1.0f, comma 1.0f, comma 1.0f, comma 1.0f, close curly brace, semicolon. Float 4, far color here, open less than sign, string UI name equals, in quotes, far color, close quotes, semicolon, string UI name, UI widget equals, in quotes, color, close quotes, semicolon, closing greater than sign equals curly brace 0.0f, comma 0.0f, comma 0.0f, comma 1.0f, close curly brace, semicolon. Float hither, open less than sign here, string UI name equals, in quotes here, near distance. Near distance here, close quotes, semicolon. Open greater than sign equals 5.0, semicolon. Now remember, hither is going to be your near distance, and that's something important to keep in mind when we're going through the algorithm here. Yon is your far distance. So float yon here, open less than sign here, string UI name equals, in quotes, far distance, close quotes, semicolon, close greater than sign equals 7.0, semicolon, float gamma. Alright, and then we have string here, UI widget equals slider here, close quote, semicolon, float UI min, 1.0, semicolon, float UI max, 5.0, semicolon, float UI step, 0.05, semicolon, string UI name equals, in quotes, gamma roll off. Now, if you want, you could come in here and set this up with a whole fall off setup here if you wanted to for your slider, if you want to set up a slider beyond just a name here. So if you wanted something like that, that's totally fine. It would be easy to do. And then as far as min distance goes, I would say you do 1 to like, oh, I don't know, 50. And then your far one would be something more like boom, like that, like that. Sorry, I want to make them sliders now. Sounds like me. I don't know. Furthest distance here. Let's try to keep it where they're close to each other with only 1 unit separation. I don't know, something like that would be great. Now if I compile it, these will now have sliders. Yeah, and then now we can do this right here with them. Oh, I thought you might like that. Just to, make it a little easier to control. Okay, that works. So there we are. Now those sliders are in place, and we now have sliders to work with for this, which is pretty cool. I just thought it'd be cool to be able to do that for the sliders there to control that far off distance and everything. 8's not too bad. I don't know. Yeah, 7 works out pretty good too, though. 7's probably actually a little bit better tuned in for really seeing the effect, but there you go. There it is with sliders. Alright, so we have our float gamma here. Open less than sign here, string UI widget equals, in quotes here, slider, close quote, semicolon, float UI min equals 1.0, semicolon, float UI max equals 5.0, semicolon, float UI step equals 0.05, semicolon, string UI name equals, in quotes here, gamma roll off, close quote, semicolon, greater than sign equals 1.0, semicolon. Alright, so our struct, now this is a little different, guys. And that is that this is going to be a float 4 here for our UVW text coord, and that's because we're having to deal with the colors on part of this, and we're having to deal with 4 float values for doing our calculations. So do make this a float 4 instead of a float 2. I know that's different, so but anyhow, float 4 here, and we're not actually representing UVW. We're actually going beyond that with this color. So it's actually 3-dimensional for the color values here. They're being represented, and it's getting created off of the actual vertex points. We're just passing them in to the color channel for the fragment so that it appear as pixels. And then we linear interpolate it too. Do a linear interpolation, sorry. All right, so again, it's float 4, of course, for position, as always here for our VS out, and there's float 3 for coming in. It's float 4 here for our UVW. And then our color here is just a float 4, as always, coming out of the fragment shader. All right, so in our main VS here, VS out here, out dot position equals mole here, world view projection, comma, float 4, in quotes, in parentheses, in dot position dot xy. And I'll tell you what, because I have enlarged this, now there's a cool trick when my students happen to find it by mistake. If you hold down Control and roll your mouse wheel, you can actually change the size of your text. So no more will the text be too small to read on the screen. I'm actually able to enlarge it for once. It's not a GUI option in here, it's a special hotkey combination that isn't real apparent, but there it is, and it will let you make it bigger for the text so you can actually read it easier. Out.position equals mole here, world view projection, comma, float 4 here, in.position.xyz, comma, 1, close parentheses here, semicolon. So again, we're just making this go from non-homogeneous to homogeneous coordinates for our position. Float DL here equals out.position.z minus hither, close parentheses divided by yon minus hither, close parentheses, semicolon. Okay, so what is this? All right, so remember Z is going what direction? Into the screen, right? Okay, so that's important to realize and understand. That means that we're actually finding our point on our surface. Remember, this is a vertex shader, right? So we're finding our vertex point in space, and we're subtracting the hither, or what's the hither, guys? The what? Near, right? Near distance, and your yon is your far distance. That's correct. Okay, it's important to understand. So what are we doing here? We're saying, all right, let's find the distance between the near and our current position in the scene. Okay, cool. That's what this does. So it finds that position. And then this one finds what? Far distance subtracted from the near distance. So this gives us only the span of space for our overall values that we're doing our depth on. So what does this mean? It means we're doing our depth calculations over a distance of 2 in this case, right? Because our near is 5 and our far is 7. So that means we're only dealing with this little block. So you see, for instance, think of this entire world here, and this gray space is your overall actual space in the world, right? Well, we're saying that, for instance, this little edge right here on this cube would be the near, and then this other edge over here on the other end of the cube is our far one. And we're only looking at the actual depth or the distance between those two. So that's what we're doing here. So when I subtract this one from this one, I find out the space in between here. And that has to do with this right here too. For instance, we have a position on our point on our surface here, and then we have this far one is here. Our near one is like, say, this edge here, right? So from this point, only in Z though, not for X and Y. So, you know, what's the distance here from the near to that point? That's what we're finding here. And since we're dividing this by our overall range here in our depth between, which is given to us by yon minus hither, right, which is our near from our far distance, and divided by our position of our point here subtracted from the near, that's going to give us basically a fraction percentage amount. So we're going to say how much, basically what we're saying is how much of a distance into this space are we on this point. So it's letting us find the distance back in the depth wise of where we are on this point within this space. That's basically it. Then we go ahead and we cap it, or clamp it, shall we say. So we set up a min here for a DL to go as a minimum of 1.0 and a max of 0.0 here for the DL. And then we go and do our gamma here on it. And the way to do the gamma is just do the DL by to the power of gamma. And what that does is lets us cause this brightening effect, just like you would speculars. We're doing the same kind of thing here with the gamma. So we're just taking it to the power of, and it gives us this nice brightening effect on it. And that works nicely. And then from there, we're just going to do a linear interpolation, which lets us blend from our near color to our far color based on the percentage value of our DL. Remember that we calculate our DL up here as what? Where it is and within the space and depth, as far as that goes. And then here we're doing a linear interpolation here, color from far. So this lets us determine which color it should be in this range from near to far here for the color. And remember, our near color is what? White, and our far color is black. So we're saying between white and black, and then this is the value here, what is it going to be for the blend? And then so because we've calculated this position within the space here, you know, we're going to get the color to match that. And so you don't have to worry about it. It's like, well, what if we're doing a gamma here? Now remember, these are uniform variables, right? So since they're uniform variables, they're not changing many times over throughout the scene. So because of that, oh gee, Christmas, did I remember to make these uniforms? No. Okay. So you may want to do this on each one of these because that will optimize it further. Because these aren't going to change, these are not varying variables, so they're not going to change many times throughout the entire scene. This is more for understanding this, because this is used, this technique is used in many shaders coming up actually. So you'll see depth shader how to access that information and manipulate it. Something that's done on a regular basis pretty much in a lot of shaders for doing different calculations. It's really important for a lot of different things. So I didn't want to jump ahead on some stuff until we covered how the depth works here. So this gives us our linear blend here, or your depth color if you want to call it that. It's the UVW, but here's your UVW on it, and we're doing a lerp here. And it's letting us find what color is at each vertex point based on the distance of that point within inside the space. Basically, that's it in a nutshell. Just realize that, you know, this point here is somewhere within this space, and we're finding out, okay, so it's this amount of space in here, so it's about this percentage of color from near to far, and it's going to end up being this color here from our blend for our linear interpolation. Because remember that linear interpolation is going to go from white to black, and we're saying where within inside that white to black distance here. So if you think about this as your far white, and this is your far black, we're saying based on how far back in here we are within this distance here, that is determining the color on the surface for how white or how black it is, essentially. That's what this shader says. And this actually does that value assignment here, whereas this determines the position percentage amount here in the shader, and then this clamps it to make sure it's within a certain range, and then this does a whole overall brightening effect if you want on it to make it brighter or darker or whatever. Okay, that's pretty much the shader. Let's look at wrapping it up now. Okay, so we're going to return out here, and then fs out here, main ps here, vs out, in. None of this changes. This is changed though. You're going to do a float 4 here for your color out. You're going to say float 4 here, open parentheses, in.uvw.rgb, comma, 1.0, close parentheses, semicolon, like that. And then from there, once you put that in there, the rest of this is all the same. So you don't even touch it. It stays the same. And it does work with ARB VP1 and ARB FP1. So it's just a simple color manipulation, so of course it works on the older programs. So this will work on any card known to man, pretty much. But essentially that's it. That's the shader, and that's everything as far as that goes. So again, you don't have to do anything for this stuff if you're copying it from your screen space pass-through, as it is identical to that other one. Okay. And so that should just be a follow-through on it. And then you should be able to save and compile and get this result and be able to play with these values. But with that covers the depth shader, and this is important when we go into screen space, ambient occlusion, or some of the other shaders out there, depth of field. This is used for depth of field a lot, quite often actually. And based on these values, you can pass it in to determine a blur amount or whatnot, and then you can blur it based on this depth color. And in this way, you can do a depth of field for what's in focus and what's out of focus, essentially. That's one technique for doing a focal lens blur system for doing depth of field. We'll get into that later, but you can start to see, okay, this technique here is really important for us doing these other techniques. So I had to step back for a moment and go, I am getting ahead of myself. And I'm wanting to cover these cool techniques like, lens depth of field, and I don't know, I'm wanting to do night vision and screen space ambient occlusion and screen space global illumination and all these fun stuff. However, in relief mapping and parallax mapping, of course, those don't rely on this, but I need to cover some of this other stuff first. I also want to do BRDF, but I need to cover some mathematical shaders on blend and anisotropic light models and things of that nature before we try jumping into some of that stuff. So we're going to cover some of these other techniques first and foremost, and then we can move into those other shaders. And it's really important that we do it in that way. Okay, but with that, that covers depth shading here. My name is Nate Nestler, and this is for Hyperactive Studios. Thank you very much.